Hello everyone, welcome to another video of General Mathematics of class 10, and today we are going to start chapter 4, that is quadratic equations. So first of all, what is quadratic equation? Let us understand that. Then we have a standard form of quadratic equation, we have a pure form of quadratic equation, then we will move to exercise 4.1 and see how to solve the given sums. So this is going to be a content of the video. So first of all, what is a quadratic equation? Now, quadratic equation means an equation whose degree is 2. Now, what do you mean by degree? Degree of an equation means the highest power of the variable. If the highest power of the variable in an equation is 2, then the equation is a quadratic equation. Let us take one example. Suppose we have an equation here, twice x squared plus 4x plus 3 equal to 0. Now here the variable is x. And what is the highest power of the variable? The highest power of the variable is 2. Therefore, the degree of this equation is 2. As the degree is 2, it is a quadratic equation. Let us take another example. Suppose twice x cube plus 4x square plus thrice x plus 2 equal to 0. Here the degree is not 2, rather it is 3, the highest power. See, here the power is 1, here the power is 2, and here we have the power 3. So as the highest power is 3, the degree is 3, it is not a quadratic equation. Okay, this is pretty simple. Okay, so if we have the highest power of the variable as 2 in any equation, then that equation will be called quadratic equation. So this is what we mean by a quadratic equation. Now let us see what is the standard form. So now we will look into the standard form of a quadratic equation. Now the standard form of a quadratic equation is this: ax squared plus bx plus c equal to 0, and in this case a should not be equal to 0. Okay, so a, b and c are the constant terms, means any number. It may be any integer, it may be, it can be any integer or any decimal, so it can be any real number. Okay, so rational, irrational, anything, a, b, c are constant numbers, and x is the variable. So this is the standard form. For example, if I write one example, it is like thrice x squared plus 4x plus 7 equal to 0. So what do we have here? A is equal to 3, b is equal to 4, and c is equal to 7, and x is the variable. So we have written this with an example. So ax squared plus bx plus c is equal to 0. Here the highest power of the variable is 2, therefore it is a quadratic equation, and this is called the standard form. Remember, a should not be equal to 0. Okay, a should not be equal to 0, because if a is 0, then what will happen? If the value of a here becomes 0, then it will become something like this: 0 into x squared plus bx plus c equal to 0. Then this becomes 0 plus bx plus c equal to 0. So it is bx plus c equal to 0, which is a linear equation. Here the highest power is 1, therefore it becomes a linear equation. So as a result, the highest power of the variable should remain 2, and hence a cannot be equal to 0. Okay, I hope you got the points. This is the standard form. Now if from this equation itself, if we take, if b is equal to 0, then what will happen? Just putting the value of b as 0, what do we get? We get ax squared plus 0 into x plus c equal to 0. So it is ax squared plus c equal to 0. This becomes 0, so no need to write it again. So here we have ax squared plus c equal to 0, and this is called the pure form of a quadratic equation. Pure form means if the variable will be present and the variable will only contain the highest power, that is 2. Okay, it will not contain any other power. So here we had x having the power 1. So in a pure form, this x to the power 1 term will not be available. What will be available is only the term containing x to the power 2, the highest power. So ax squared plus c equal to 0. Obviously a cannot be equal to 0 is the pure form of a quadratic equation. So this is our standard form and this is our pure form, ax square plus c equal to 0. Done. So this is about what is quadratic equation, what is the standard form, and what is the pure form. Now let us move into exercise 4.1 and see how to solve those sums. So let us see what are the questions that we have. We have to check whether the following quadratic equations, following equations, the given equations are quadratic or not. So let us take one or two sums and see how to do it. Question number 1, and here we have number 1. What is here? X plus 1 whole square is equal to 2 into x minus 3. So what you need to do here is simplify. You simplify the equation and bring it to the standard form, and you will understand whether it is a quadratic or not. So it is x plus 1 whole square means x square plus twice x plus 1 equal to twice x minus 3. So see, twice x will cancel out obviously. So we have x square plus 1 plus 4 equal to 0. We have done, extremely sorry, plus 3 equal to 0. So we have x square plus 4 equal to 0. So since here the highest power of the variable is 2, so since degree is equal to 2, therefore the given equation is quadratic. Okay, I hope it makes sense. So what we have done here, we have solved, we have got it to the standard form or the pure form. Here we have b is not available. So here the degree of the polynomial means the highest power here is found to be 2. So therefore it is a quadratic equation. Let us try one more. In this case, let's try number 3. Question number 3. What do we have in question number 3? We have x minus 2 into x plus 1 is equal to x minus 1 into x plus 3. So now break the brackets. Okay, x square minus 2x plus x minus 2 is equal to x square minus thrice x, x square plus thrice x minus x minus 3. So x square will cancel out. We will have here from these two we have minus x minus 2 and equal to, here we have 2x minus 3. So if we get a side change, minus x minus 2x minus 2 plus 3 is equal to 0. So it is minus thrice x plus 1 equal to 0. So here degree, what is the degree? The highest power of the variable is here is 1. So since degree is equal to 1, therefore the given equation is not quadratic. Okay, so hence the given equation is not quadratic. Understood? Very simple. So likewise you can go ahead and do some of the sums. What you need to do basically is get the equation, means whatever equation is given, try to solve it, get it into a standard form, means you simplify it, bring all the terms to one side, you find the standard form of the equation. Once you find the standard form, see what is the power of highest power. If the highest power is 2, then it is going to be a quadratic equation. If the highest power is not 2, then it will not be a quadratic equation. As simple as that. Okay, so let's move on to question number 2. Let us remove this part. So in question number 2, what they have said, they have given us some word problems, and we have to represent it in quadratic equation form. Only representation, no need to solve the quadratic equation. You have to represent these statements into quadratic equations. So question number 2, let us try one or two sums. For example, let us see for the first one. Okay, question number 2, Roman 1. what do we have here? The area of a rectangular plot of land is 528 meters square. The length of the plot in meters is one more than twice its breadth. We need to find the length and breadth of the plot. So the area is given 528. So let us write, given area of rectangular plot. Area of rectangular plot is 528 meters square. The length of the plot is one more than twice the breadth. That means the length has been mentioned in terms of the breadth. So what we will do, let the breadth be x meter. Therefore, the length will be equal to, length is one more than twice the breadth. So breadth is x, so it will be twice x plus 1. Twice the breadth and plus 1 will be 1 more than twice the breadth. So now according to the question, the area of the rectangular plot is 528. Now area means length into breadth. For a rectangle, the area is length into breadth. So what is length? Length is twice x plus 1 into the breadth will be equal to 528. So again, let us bring it to the standard form. We'll break the bracket, side change equal to 0. This is the required quadratic equation. So that's how you represent. Okay, that's it. As simple as that. No need to solve right now. If it is asked in the questions in which you will be asked to solve, you will solve. Here they have not asked you to solve, so no need to solve. Okay, I hope it is clear. Let's move on to another one. Actually, let's move on to number 4. Okay, number 4. 2 and 3 you can easily do. These are very simple sums. Okay, a train travels a distance of 480 km at an uniform speed. If the speed had been 8 km per hour less, then it would have taken, where does it go? Yeah, 3 hours more. So if not represented in quadratic equation form. Okay, so it has said that if the speed had been 8 km per hour less, then it would have taken 3 hours more for the journey. Okay, so what has been given? Let us see what is given. The distance has been given. Okay, distance of 480 km at an uniform speed. So given distance traveled by the train is equal to 480 km. Okay, if the speed at an uniform speed, so we need to find the speed. At the end of the question they have asked, we need to find the speed. So for finding the speed, we need to assume that let the speed of the train be x kilometer per hour. Okay, we have assumed the speed of the train to be x kilometer per hour. Now according to questions, we will write some of the things. So this is our speed, x is the speed, we have the distance, it is 480 kilometer. Now in order to form an equation, we need to find the time that the train has taken, right? Now what will happen if things change, like if the speed had been this 8 kilometer less, then time would have been 3 hours more. That is okay, but before that we need to understand what is our time going to be. So therefore time taken by the train, what is the time taken? Now see, we all know the speed is equal to distance by time, right? That means time will be equal to distance by speed, right? This is the formula for time. Time is distance by speed. So what is the time here, distance here? 480. And what is the speed here? It is x. So we have 480 by x hours. Okay, so this is our distance traveled. Speed has been taken as x, and time taken by the train is now 480 by x hours. Okay, now let us see how can we form the equation according to the question. So according to the question, it has been said that had the speed been 8 kilometer per hour less. So our speed is x. Had the speed been less by 8 kilometer, so minus 8. Now I have what I have done, I have reduced the speed by 8 kilometers per hour. Then see, distance will remain the same. I am using the formula speed is equal to distance by time here, okay, in this case. So this is our speed, right? Speed has decreased by 8 kilometers, so x minus 8 is equal to distance. Now, distance is 480. Distance will remain the same. There is no change in distance. Time, the time would have been 3 hours more. So what is our time? Our time is 480 by x, and time would have been 3 hours more. So this is the equation, our required equation. From here we will just simplify it. So this will be 480 plus thrice x by x equal to 480. So x minus 8, 480 plus thrice x, side change of x will give us again 480x. So if we break the bracket, 480x plus thrice x square minus 0, 64, 6, 32, 3, 8, 40 minus 24x is equal to 480x. So 480x here and 480x here will cancel. We have 3x square minus 24x minus 3840 equal to 0. From here you can take 3 common. I will have x square minus 8x minus 1280 equal to 0. So it is x square minus 8x minus 1280 equal to 0, and this is the required quadratic equation. So here is the sum, question number 4. This is a bit complicated compared to the other sums that we have done. So that's why I've tried to show you this, because here the speed will change, time has not been given, nothing has been given, only distance has been given, nothing else has been given. So since we know the formula of speed equal to distance by time, you can find out these values accordingly. Okay, so I hope you understood, and here we have come to the end of today's video. It is a small video, so in our next videos we will move on to exercise 4.2 and exercise 4.3. So hope you've understood. Thank you everyone for watching, and until next time, cheers.